Okay, so this is 1 out of 3 videos. Hopefully that it will clarify a lot of the confusion on parabolas. So we're going to look at vertical parabolas first. So that would be of the equation y minus k equals a times x minus h quantity squared. All right. And so first we're going to look at a. A is equal to 1 over 4c. And that tells us how fat or skinny our parabola will be. If it is a fraction for a, then it's going to be a fat parabola. If it's a whole number, then it's going to be a skinny parabola. Okay? And the reason why it's important to use this method to find a, 1 over 4c that is because c is the distance between your focus and your vertex, and as well as your vertex and your directrix. Okay? Now, the different formulas we have. So we know that vertex comes from the function, which is h comma k. Okay, so h goes with x's and k goes with y's. And then your focus is h, k plus however large of a distance, so c. And then your directrix is y equals k minus c. And your axis, as always, is the x-coordinate of your vertex. Okay? So let's look at a couple examples of what we could see. For example, like on the quiz, what if you're given the equation of the parabola and you're asked to find the vertex, the focus, the directrix, the axis, and then graph, right? So first thing you do is figure out your vertex. Your vertex is hk, right? Where h is from this portion of the function and k is from here. So whatever number is attached to y, that's going to be k. Whatever number is attached to x is going to be h. And then we had to figure out focus and directrix. But here's the problem. Focus and directrix rely on c. So we need to find that. And in order to find that, we're going to set a equal to 1 over 4c and solve for c, because we know what a is from the original equation. And then we plug in c to our focus formula and our directrix formula. And then, so directrix should always be away from the graph. So if your directrix is in the middle of your parabola graph, then something's wrong. It should be directrix, focus, vertex, graph. Okay, so directrix is somewhere away from the rest of the function, whereas the focus should be in the middle of your parabola, always. Okay, the focus should always be in the middle of your parabola. All right, let's look at when you're given the vertex and the focus. The first thing you have to notice is that vertex and focus, if you're only given those two, the way to tell which parabola you have, right, because that's a big problem, is you need to look at the coordinates of each point. If the x-coordinates are the same, then you have a y equals parabola. Okay, and then so once you know that, you can start figuring out the rest of it. Now, you know what h is and you know what k is because you have the vertex. But the problem is you don't know how to figure out a, right? And the only way to figure out a is to solve 1 over 4c. That's the only way to find a. And the nice thing is, though, that we can find c. We find c by setting k plus c equal to y coordinate of the focus, and then solving for c. And so once we have our c, we plug that in to 1 over 4c, and we get a. And then once we have A, we plug our A and our vertex into equation. Okay? Now let's say this time we're given the vertex and the directrix. So the nice thing is that if you're given the directrix, you automatically know which parabola you have. And that's because if the directrix is y equals, then it's a y minus k equals a x minus h squared parabola. Okay, as soon as you see y equals, you know you have a y parabola. And so then what's nice about directrix is that it's very similar to the format of finding the equation of the parabola given the focus, okay? So we know that we have h and k because we're given the vertex here. So all we need to find is a again. And we know that a is equal to 1 over 4c, so we need to find c. And so the way we find c is we set k minus c equal to the number value of the line of directrix. So if directrix is y equals 6, then it's k minus c equals 6. Okay, so we set the k minus c equal to the value we have for our directrix, and then solve for c. Now some of you are probably like, well, we have two variables just like we did in the last one, and we don't know what k is, but you do, okay? You always have k because k is part of the vertex, so don't forget that. And so then once you have c, you can plug back in to 1 over 4c, which is a, and then plug a and vertex into equation for parabola. And that's it. The last type is, say you're given the focus and the directrix. Now this is where it gets a little tricky. So remember that the definition of a parabola is the set of all points equidistant from the focus and the vertex and the directrix. So directrix is down here, focus is up here, and this is my parabola in the middle. So these are supposed to be equidistant. I know my drawing doesn't look equidistant, but they are supposed to be equidistant. So that means if I take any point on the directrix and any point on the focus, those two dotted lines that I just drew have to be equal. So one way to solve for this is to pick any random point on the parabola. Okay, and then solve for the distances from focus to the point and directrix to the point. And then because they're equidistant, they have to be equal to each other. Okay, because directrix and focus are equidistant from parabola. Okay, and then you solve using distance formula. And this method will always produce the equation for the parabola. Equation for parabola. So if you end up with some random points or a number, you did something wrong. You should get the equation of the parabola using this method. The other way to figure it out if you're given focus and directrix is to figure out the c by solving for the vertex and then plugging that into how we did it in the last two slides. So lastly, I want to quickly mention graphing of these. Now I think everyone's just making graphing a little harder than it actually is. So once you have your vertex, your focus, your axis of symmetry, and your directrix, you need to graph each. Okay, so in this case, we'd have a y equals line for our directrix. So let's draw that here. Let's say y equals 4. Okay, and then let's say our vertex is 0, 0, and our focus is 4, 0. So focus, vertex, 4, 0, 0, 0. This should make sense because your distance between your vertex and your directrix is 4, and the distance between the focus and the vertex is 4. Okay? And then the axis of symmetry is the x-coordinate of the vertex, so that would be 0 right here. Okay? Now, to figure out how thick or thin your parabola is, the best way really to graph that correctly is to do a quick t-chart of x and y values. And I would just pick, 2 or 3 points, that's it, and then plot. So we could pick like 1, 0, -1, and then you graph it. So you've got 1, let's say it became, I don't know, if C is 4, then A would be 1/16. So if we plug in 1, that'd be 1/16. So that'd be down here. -1 would be the same thing. And 0, 0 is the same thing, is 0. So we just draw our parabola like so. And that's it. Okay, that's how you would graph those. I'm hoping this video made a little more sense on as far as the parabolas go. I really, really suggest you guys figure out a way, some sort of anagram or some sort of like quick song so you can remember all the different formulas that you have to know by Tuesday/Monday, depending on what class you're in.